Hello my dear students, this is your online English medium combined mathematics class. I am Rajika Wimalarathne. So today is the 6th day of your online English medium combined mathematics class. So last 5 days we have done the things about binomials, factorization, algebraic fractions and equations. So today also we need to go further with equations, especially quadratic equations. So when we are doing quadratic equation, we get some imaginary solutions. Then we have to analyze imaginary numbers and complex numbers as well. So today I am going to do imaginary numbers, complex numbers and solutions of quadratic equation by using complete square method and direct formula. Okay, let's start from the beginning. Okay, let's start today's session. So last day I done up to complete square method, no? I done up to complete square method. Today we need to go forward. Then I just rewind you complete square method first. Then you consider ax squared plus bx plus c equals 0. We call quadratic equation. Here quadratic equation. For quadratic equation, we have two solutions. We call they are roots. Solution we call roots. So here x equal minus b plus or minus b square minus 4ac root divided by 2a. Here these are the solutions, roots. So these solutions we obtained by using complete square method. We obtain that solutions by complete square method. Okay, the method is this. You consider equation ax squared plus bx plus c equals 0. C equals 0. You have to practice this complete square method. You have to practice this one. Here ax squared plus bx plus c. First, we define this ABC as real values and a not equal to 0. A not equal to 0. Okay. Then if a 0, then this term will disappear. Then further that one quadratic. No? Further that one quadratic. Now to subject x, we use complete square method. Here first step, you divide by a, then x squared plus b divided by ax plus c divided by a. Here 0 divided by a. Then 0 divided by a, we know that is 0. Then next step, you get perfect square. Here x square you write as x and this plus sign you write same here. Then b divided by a. No? Here take x coefficient, you divide that x coefficient by 2. Then we write here b over 2a without x. Okay. Then here we have c divided by a. So you expand this one in your mind. Here this is binomial expansion. Then here x square there plus product of these two times 2. No? Then 2x into b over 2a, then we get b over a x. That also there. Then b over 2a square again will appear. Then b over 2a square we don't have here. Therefore you have to remove that one by removing b over 2a square. Now here the relation. Now x plus b over 2a whole thing square, take the other two terms the other side. Here b square divided by 4a square minus here c divided by a. Now we get that. Thereafter simplify, get common denominator 4a square, then here b square minus here 4a square needed, then you multiply here by 4ac. Then get both sides square root, x plus b over 2a whole thing square equal, here take square root. No? Then b square minus 4ac divided by 4a. Here you have to put plus or minus. Okay. Then here x plus b over 2a equal plus or minus b square minus 4ac divided by 4a square. Then x equal, put this on the other side, minus b divided by 2a plus or minus b square minus 4ac divided by here we write 2a root. Then final answer x equal minus b plus or minus b square minus 4ac root divided by 2a. Okay, that's how we obtain it. This process is called completed square method. Definitely you have to practice this completed square method really well, okay? Because we need this quadratic relation in our A levels. We have a lesson called quadratic functions and quadratic equation. There we have to practice completed square method. And also when we are doing questions, we will get quadratic relations, usual quadratic equations there, then we may need to apply this relation directly, okay? Then I'm going to practice today this completed square method and further quadratic relations. Okay. Now before that, see this one. So you consider numbers. Okay. So you know numbers 0, 1, 2, 3. It goes like that, no? Up to infinity. These are numbers. Usually we denote this one by natural numbers, n letter. Natural number. Then here infinity, very large number, but we don't know exactly what the value there. We don't know exact value, but you have to identify that one, very large number. Then further you consider integers. Then there are negative values for these natural numbers. Here positive 1, then here minus infinity, minus 2, minus 1, 0, 1, 2, 3 up to plus infinity. These are belongs to integer set, okay? Then for this part we say positive integers, for this part we say negative integers, and for this part we say non-positive integers. Negative integer is 0, and here to here we say 0 to infinity we say z plus with 0, non-negative integers. Okay. Here natural numbers, integers, and further you know rational numbers, so no, real numbers, you have analyzed that. And when we are doing quadratic relations, we will get another new number set we call imaginary numbers. Let's analyze that one today from the beginning. Okay, write down today's topic. Imaginary numbers. Okay, new topic, imaginary numbers. Okay, this is set very new to you. Huh? Just write down square root of negative number represent an imaginary number. Square root of negative number represent an imaginary number. Square root of negative number represent an imaginary number. Okay. You write here minus square root 4, minus square root minus 5, minus 3 square root, minus 1 square root, minus half square root. These are imaginary numbers. Write examples. Imaginary numbers. Within square root negative value. Huh? Within square root negative value. Okay. Now here you generally write negative square root imaginary. here imaginary. Within square root negative, but write down that one. By side write down. Imaginary equal negative square root. Okay, for that case we don't have further simplifications. We have only notations to represent that. Okay, with star mark write down. With star mark write down. For imaginary numbers, there's special notation I. There's special notation simple I. There's special notation simple I. Okay, here it is. Minus 1 square root equal I. This is the one. Minus 1 square root equal I. If you see any square root with minus 1, you say that is I. That's it. So if you square this one, minus 1 equal I squared. This is standard notation. Minus 1 equal I squared. Minus 1 equal I squared. Okay. Further see, here take minus 4 square root, check this simplification. Here you write minus 1 root times 4 root. Then minus 1 root mean I, square root 4 mean 2. Then that is 2i. Then this is imaginary. That's how we just simplify, okay? We need to only represent that one. That's it. Then minus 9 square root. Here minus 1 times minus 1 square root times 9 square root. Okay, you can split this one. Then minus 1 root, we know that is I, 9 square root 3. Then here minus 3i. That's how we simplify. That's how we simplify. See, minus 1/4 square root. You do this way. Minus 1 root into 1/4 square root. Then here I into half. I divide by 2. Likewise, you can simplify, okay? New notation, new number set, that is called imaginary. Imaginary. Okay, write them all. Okay. Now just you identify square root of negative number, you say it is imaginary. Okay. So in your O levels you don't know this one. Now you know that is imaginary. Square root of negative number imaginary. So as notation we have to use minus 1 square root equal I. Then when you square both sides, minus 1 equal I squared. Then minus 4 square root, we write minus 1 root times 4 root. Then here I times 2, 2i. Then minus 9 root. Here minus 1, here minus 1 root into root 9. Then here root 9, 3, minus 1 root I, minus 1. Here minus 3i. Okay. Then similarly here, minus 1/4 square root. You split here, minus 1 root, 1/4 square root. Then minus 1 root you say I, then 1/4 square root half, then I divide by 2. That is imaginary number. A new number set, minus 1 root equal I. That is very new to you. Okay, now further see. Consider here I cube. So if you have I cube, you just write I square times I square times I. Okay, I square we know minus 1, no? Then always if you see I square, you put minus 1. Then here minus 1 times I. Here minus I. Then I to the power 4, you say I square to the power 2. I square means minus 1 square, it is 1. Then I to the power 5, I square to the power 2 times I. No? Then I square means minus 1 square times I. Here I. Then I to the power 1001, let's say. Then here I times I square to the power 500. Then I square means minus 1. Here I square means minus 1 to the power 500. Then minus 1 to the power 500, 1. Then we have 1. Likewise, we can simplify these relations. We can simplify. For imaginary numbers, identify, we have minus 1 square root equal I. That is very standard notation. Nah? Anybody can't change that one. That is standard notation. Then you can apply that for minus 1 root. That is standard one. Here, that is in imaginary one. I mean, we call imaginary one. Just one we know, that is real one. No? Likewise, imaginary one, we say I. Okay? Which star mark write down? Imaginary one is denoted by I, simple I. Imaginary one is denoted by simple I. And all imaginary numbers can be represented geometrically. All imaginary numbers can be represented geometrically. On the imaginary axis. Okay, now you just sketch with me. Here number line, you say IM, that's how we represent imaginary axis. So you know real number line? Here real number line, it has 0, 1, 2, 3, minus 1, minus 2, minus 3, so on. Then imaginary number line, it has imaginary 0. We represent by 0i, imaginary number. Then here 1, here for 1 real 1, then imaginary 1 we say I. Here real 2, likewise imaginary 2, 2i. Here imaginary 3i. Then minus, imaginary minus 1, imaginary minus 2. It goes on, imaginary minus 3. So anyway, if you identify 3i mean 3 minus 1 root. I mean minus 1, 3 minus 1 root. Here it is. 2i mean 2 minus 1 root. I mean minus 1 root. Here I mean minus 1 root only. Then 0i mean 0 times minus 1 root. It goes on. This is we call imaginary axis. imaginary axis. Then we have imaginary 1, imaginary 2, imaginary 3, imaginary half, imaginary 1/3, imaginary square root 3. We have them, okay? Then if you need to simplify this, minus 3 root, then here minus 1 root, square root 3. Then you see here I, here root 3 I. Then here imaginary root 3, no? Imaginary root 3. Okay, that is imaginary numbers. Anyway, now you sketch this one. Here real number line, here imaginary number line. Real number line and imaginary number line. Represent them. Okay. Now, thereafter you write this one, simplification of power 5. Write this one. Okay. Now you try to simplify these relations. I need simplest form. I to the power 5, 6. I to the power 7. I to the power 11. I to the power 16. I to the power 101. I to the power 102. Okay. Simplify them. I need simplest form. I need simplest form. Anyway, you remember I square equal minus 1. I square equal minus 1. Take that relation and do simplification. Take time. Okay, time's enough. I square to the power 3 Here minus 1 cube minus 1. I square to the power 3 times I minus 1 cube times I minus I times I square to the power 5. Then I minus 1 to the power 5. Here 10, 1, 11. Here minus I square to the power 8. Then minus 1 to the power 8 plus 1. Here I times I square to the power 50. I minus 1 to the power 50, that is I. Then I square to the power 51. Then minus 1 to the power 51 minus 1. Then we can write that relation in terms of I or without I. With I or without I. Okay. Okay. Now with another star mark, write down. With another star mark, write down. All imaginary numbers are obeyed with algebraic operations. All imaginary numbers are obeyed with algebraic operations. All imaginary numbers are obeyed with algebraic operations. Okay, now see this one. So this is just only introduction part of imaginary numbers, but your A level there will be in pure mathematics lesson called complex numbers. So in that complex number we have imaginary number part. Okay. Then complex number, really important section, complex number. Then complex number mean addition of real and imaginary numbers. So I'm going to tell you here algebraic operations. You consider 3i, 5i. So when you add, you get 8i, general way. Then 5i minus 2i, you get 3i. 4i times 2i, here you get 8i square. You know I square minus 1, no? Then minus 8. 4i divided by 2i. Cancel I, cancel 2, that is 2. You can cancel I because 4i mean 4 times I. 4i mean 4 times I. Here divide by 2 times 2i mean 2 times I. Then you can cancel I terms and cancel 2 terms. We get 2. This is we call addition. Here we call subtraction. Here we call multiplication, and here we call division. You know these algebraic operations with real numbers, no? You know these algebraic relations with real numbers. And likewise, with imaginary numbers also you can apply same algebraic operations. But there's some specialty here. When adding two imaginary numbers, result will be imaginary. When subtracting two imaginary numbers, result will be imaginary. But when multiplying imaginary numbers, then this I will disappear, no? Then by this multiplying imaginary number, result will be real. Then by dividing also we can cancel I, no? Then I will disappear, then this part will be real. Then multiplication, division of two imaginary number represent real numbers. But for addition and subtraction, that represent only imaginary number, no? That's the specialty. That is specialty. Okay. Write down operations. Just write down examples. Okay. Then with star mark write down. When adding two imaginary numbers, when adding two imaginary numbers, or subtracting two imaginary numbers. When adding two imaginary numbers or subtracting two imaginary numbers, represent an imaginary number. Represent an imaginary number. Represent an imaginary number. Represent an imaginary number. But when multiplying or dividing two imaginary numbers, when multiplying or dividing two imaginary numbers, represent a real number. Represent a real number. Okay. Now here 3i plus 5i. No? Here 5i minus 2i. Sum of two imaginary numbers. No? Can check this one further. So you know 3 plus 2, it is 5. No? 3i plus 2i, it is 5i. Then 3i plus 2. 3i plus 2. Same type numbers we can add it together. No? 3 plus 2, 5. 3i plus 2i, 5i. Here these two real, these two imaginary. Here one is real, the other one is imaginary. It's very complex, no? We can't add real numbers and imaginary numbers. Therefore, further we say this one complex. We can't further simplify. Here we can simplify. Here result real, here result imaginary. Okay? Here this is complex number. That is the introduction of complex number. Addition of real and imaginary number we say complex number. You know up to real number set under O levels. You know natural numbers. You know counting numbers. No? You know positive integers. You know negative integers. Okay? You know integers. You know rational numbers. No? Then likewise we have a new number set we call imaginary numbers, and further we have complex numbers. Imaginary numbers, then complex number. You say here complex number. 2 minus I, complex number. 4 minus 1 over 2i, complex number. Here root 3 plus I, complex number. Okay, all are complex numbers. So you consider 0 plus I, that also complex, but it look like imaginary, but we can consider 0 plus I complex. Then 5 plus 0i, this is imaginary, this is real. Therefore this is complex. Therefore anyway, here this number you can say imaginary, and as well as that is complex. Then this one we say real, but again we can say that is complex. So anyway, real numbers you can consider as complex number, imaginary number also you can consider as complex number, and there's complex numbers as well. Here for this part you say purely real, here purely imaginary, purely real, then these are complex. Here, and here, complex numbers. Okay. With star mark, write down. With star mark, write down. With star mark, write down. Addition of real and imaginary numbers represent addition of real and imaginary numbers represent a complex number. Addition of real and imaginary number represent a complex number. Okay, just write this one. Just write. Okay, now see this one. You consider x plus iy format. Here you say complex number. Then x plus 0i type, that also complex, but here we say especially purely, imaginary value, purely real. Here 0 plus iy, here that is complex, and here especially we say no real value, then purely imaginary. Then for this one you can say complex, for this one also you can say complex, and for this one we usually say complex, and especially this one purely real, and especially this one purely imaginary, totally imaginary. Okay, better note that one as well. Then you identify all numbers are belongs to complex type. Okay, all numbers are belongs to complex type. Real number also you can consider like complex. Imaginary number also you can consider like complex. Okay. Okay, while you are doing questions, you get these type of relations. That's why I told you these are very important. Okay, now you see this relation. You consider x square equal 1. X square equal 1. Here x equal plus or minus 1. No? Then x square equal minus 1. Then here you say x equal plus or minus minus 1 root. Here we say plus or minus I. Plus or minus I. Okay, plus or minus I. Then see, x square equal minus 4. You say here x equal plus or minus minus 4 root. Then here plus or minus minus 4 root. Here minus 1 mean I, 4 root mean 2. Then plus or minus 2i. Okay. Then x square equal 4. X square equal 4. X equal plus or minus 2. X square equal 4. X equal plus or minus 2. Identify the difference. Yeah. Then negative 1. Here negative 1 x square equal minus 4. When we get in square root, then we get plus or minus imaginary numbers. Here real number, then here plus or minus real number. Further, x square equal minus 9, then you say x equal plus or minus minus 9 root, then plus or minus 3i. Okay, these are general simplifications. Do those examples. This is very important, plus or minus. We have two solutions, plus or minus. Okay. Now when you are doing corrections, so these are quadratic equations. These all are quadratic equations. All are quadratic equations. That's why we got two solutions. Here we have two solutions now. The process is like this. Now check this process. So when you are solving quadratic equation like x square equal 1, you take this one here. X square minus 1 0. Now here we have two factors now. X square minus 1 square 0. Here x minus 1 x plus 1 0. Then x minus 1 0 or x plus 1 0. Then x equal 1 or x equal minus 1. That's how we get. That's how we get two solutions. Then you consider x square equal minus 1, the other way. X square equal plus 1, 0. Then write x square minus 1. Write this way. Then x square minus 1 mean you say I squared. Minus 1 root I, then minus 1 equal I square. Now factorize x minus I, x plus I, 0, here x minus I 0 or x plus I 0, then x equal I or x equal minus I. That's how we take plus or minus I. So here x square equal 1, we directly write x equal plus or minus 1. Then similarly x square equal minus 1, we directly write plus or minus I. Plus or minus I. That's how we obtain. Okay, you better write them. I know you can track this one, but anyway just write them. Okay, now you see this x squared plus x plus 1 0. See this example, x squared plus x plus 1 equals 0. Quadratic equation, no? Quadratic equation. Then here's x solution, we write x equal minus b plus or minus b square minus 4 ac root divide by 2a, no? ax square plus bx plus c0, you just write x equal minus b plus or minus b square minus 4ac root divide by 2a. Here this format you can directly apply. Now check what will happen here. Then minus 1 plus or minus 1 square 1 minus 4 root divide by 2. Minus 1 plus or minus here minus 3 root over 2. Okay, that's how complex number will appear. Then minus 1 over 2 plus or minus here root 3 minus 1 root, right, I. Then here quadratic equation has complex solutions. Quadratic equation has complex solutions. Then anyway, here usual technique, you apply formula, when you are getting that, you get within square root negative value. Within square root negative value. Here minus 3 root equal minus 1 root times root 3. Then here I root 3, no? Root 3i. That's why I wrote here root 3i. Root 3i. So let's practice this one more than that. Okay, just write this example for that. Okay, you try these questions. Just apply that formula and simplify. So if you get square root, within square root negative value, then use that notation. That's it. Do it without any error. Try to do it. මොනවා හරි doubt check your simplifications. No hurry. You take your time. put bracket properly, put bracket properly. When you are simplifying, so you know 4 divided by 2, here 4 mean 2 times 2, no? Then cancel this 2, we get 2. Here 4 plus 8 divided by 2. Here 4 mean 2 times 2, 4 times 2 divide by 2. You can't cancel only one factor, you have to cancel both common with this one. Common factors, then we get answer 6. 2 plus 4, 6. Okay. If you have 2 or more terms, you have to cancel common factor. Then if you see 2 plus 8, root divide by 2. So let's do this say. Then here 2 plus, here 8 means 4 times 2 root. Then you have to cancel here plus sign separation, no? You have to cancel common 2, no? Then square root 4 means 2. Then 4, 2, 2 cancel. Then here 1. 1 plus root 2. That's how we cancel, huh? That's how we cancel. Here you have to cancel 2, and within square root again you have to cancel 4. Then root 4 means 2, no? Then we cancel common 2. Common 2. Say another one. Root 8 plus root 2 plus 32. Root divide by 2. Then 8 means 4 times 2. 2. Here 32. Here 4 times 8. Now cancel 4, that is 2, 2, and here 2 with this 2. You have to cancel all common 2 upstairs and downstairs only 2. Then here root 2, 1, here root 8, 2 root 2. Root 2 plus 1, here 2 root 2. Further you can simplify. 3 root 2 plus 1. That is 3 root 2 plus 1. Likewise, when you are simplifying, definitely you have to cancel common factors. Then I use that simplification, I use that shortcut here. Check it here. Here 4 is squared, and here 4, and here 4. So 4 mean like 2, no? 4 root, no? Then like 2. Then here we have 4 square. Then cancel this 4, and cancel 1, 4, and cancel 2. Then here with 2. Then we get 2. Here remaining 4 minus 9. 4 minus 9 minus 5. Then minus 5 root mean 5i. 5i. Okay. So when you are doing simplification, you better to apply those things. If you have doubt on this, you can write. If you have doubt on this, you can write. Okay, further you continue, no hurry, take your time. Without error you complete it. You can apply direct formula. If you get within square root negative value, you put I and do simplification. Take little time. Okay, when you simplify, carefully see this one. When you simplify, see this one. Here 2 plus 4 square minus 4 into 5 root divided by 2. So within square root you have to cancel 4 no? To remove this 2. Then cancel 4, cancel 1, 4, cancel 2 with this. Then the result will be 1 plus 4 minus 5 root. Minus 1 root mean I no? Okay. Now see this one, 2 minus 4 square minus 4 times 5 root. Yeah, if you see this type of relation. So you can cancel 4 and 2 here, but here that special thing, minus 4 to the power 2. You have to simplify this one first. 2 minus 4 square, right? 4 square. Likewise, you remove this minus sign, okay? Then you cancel 4, 2 with this 2. Then the result 1 minus 4 minus 5 minus 1 root no? I. You don't cancel 2, 4 and this 1, 4 because minus inside that. Then two different things. Therefore, if you see this type of relation, remove this bracket and remove this sign. Thereafter, you cancel 4 and 2 with this. Okay, careful do that one. Okay, continue questions. Continue questions. Take your time. One over 2 x square 1/3 x plus 5. With fraction it is somewhat difficult. With fractions it is somewhat difficult. Therefore you better to remove this fraction first. Multiply by 6. Multiply by 6 all time. Now here 3x square 2x plus 30. Now we have fraction full values, no? Then simplification easy than previous one. Minus b plus or minus b square minus 4ac divided by 2a. Now simplify 4, 4, 4, 2. Here 2 square 4, 4 cancel 2 term. Then here there will be 1, 1 minus 90 minus 89 root, then 89 root times I. So if you have fractions, first step you better to get full values. No? So here 2, 3, no? LCM 2 times 3, 6. That's why I multiply here by 6. 2 times 3, 6. Then multiply by 6. Get quadratic one, general with here full values with integers here. Now apply formula. From the initial step also you can take that, but when you are simplifying, you better to get this one first. There's simplification error here. Minus b plus or minus b square minus 4a. A means 4, no? 4ac over 2a. Cancel 2. Here 1, 1, 20. 19. 99. Okay, then 10th one, 1 over 2 x square minus 1/4 x plus 2 0, you better multiply by 4, 2x square minus x plus 8, 0. Now here the equation, x equal minus b plus or minus b square minus 4ac root divided by 2a. 1 plus or minus 64, 63. Root 63i divided by 2. 63i divided by 2. Okay. Now, while you are doing, see this one. Tell me, x square equal 1. What are the solutions here? Is it plus 1 or is it minus 1? Is it plus or minus 1? Plus or minus 1. Okay. X equal plus or minus 1. Okay. X equal, here 1 square root. Tell me the solutions here. Is it plus 1? Is it minus 1? Is it plus or minus 1? X equal plus 1, x equal minus 1, x equal plus or minus 1. Which one is the correct? For this one, this is true. But for this one, here x to the power 1, no? X to the power 1 means we have only one solution. Here x to the power 2 means we have two solutions. Then it has only one solution. Here sign plus, no? Then only answer plus 1. Not these two. Okay, don't mislead that one. Huh? X square equal 1. Here x square equal 1. X square minus 1, 0. We have two factors. Then you get answer x equal 1 or x equal minus 1. Okay. You get answer x equal plus 1 or x equal minus 1. But here x to the power 1 means we don't have any other factors. Don't square this one. Huh? So x equal root 1. Then sign mentioned in here 1 plus value. Okay. Now further simplifications. Now you see x equal minus 1 root. You say 4 What will be the solution here? Square root 4 means 2. We have minus here, minus 2. That's it. That's it. But x square equal 4. The process here, x equal plus or minus root 4. Then plus or minus 2. Then for x square equal 4, the process subject in x, when that process we get plus or minus. But here x to the power 1 equal minus 4 root, minus root 4. Then here sign minus only, but here we have to put both root, plus or minus roots. Okay. Then power 2 relation has two solutions. Power 1 relation has only one solution. Power 1 relation has only one solution. That's why we call linear type. Okay. So if you have doubt on this, better write it. If you have doubt, just write it. Huh? Okay, now you see this pattern. See this pattern. X equal 1. X equal 1. Then solution already given. X square equal 1. X square equal 1. Then here x minus 1, x plus 1, 0, x equal plus or minus 1. We have two solutions. X cube equal 1. Now you identify. Definitely that three solutions, no? Power 3, no? Three solutions. Let's see how it is happen. Then here x cube minus 1, 0. Difference of two cubes. X cube minus 1 cube, 1. We have factor here, 0. X minus 1. X square plus x plus 1. We have factor here. X minus 1, x square plus x plus 1. Then x minus 1, 0 or x square plus x plus 1, 0. Then x equal 1. There's one solution, 1. And here contradict one. No? Solve it. X equal minus b plus or minus b square minus 4ac root divide by 2a. Then minus 1 plus or minus here 1 minus 4 minus 3 root. Then minus you remove here and put I. Then one real solution, two imaginary complex solutions. One real solution, two complex solutions. Here two real solution, one real solution. Then power 1, one solution, power 2, two solutions, power 3, three solutions. It goes on. Then if you see power 4, see that one as well. 4. X to the power 4 equal 1. Then you identify there will be 4 solutions. No? There will be 4 solutions. See this, x to the power 4 minus 1 0. Here x square to the power 2 minus 1 square 0. Right, difference of 2 squares, x square minus 1, x square plus 1 0. Then x square minus 1 0 or x square plus 1 0. Then here x square equal 1, x equal plus or minus 1. Get square root. Then we get plus or minus. And here x square equal minus 1, x equal plus or minus 1 root. Then x equal plus or minus I. Plus or minus I. Here we have 2 solutions, here we have 2 solutions. Altogether we have 4 solutions. Altogether we have 4 solutions. Then identify the maximum power of x represent the number of solutions. Number of solutions. Here power 1, 1 solution. Power 2, 2 solutions. Power 3, 3 solutions. Power 4, 4 solutions. If you have power 5, there will be 5 solutions. Okay. It goes on. It goes on. Okay. Write them. Better write it. Huh? Okay. Now let's have a small interval. So then thereafter we can discuss more things about equations. Huh? Okay. Okay, now let's practice. Let's practice complete score method. Let's practice complete score method now. Now imaginary roots and imaginary solution, I have given everything. Now while you are doing questions, definitely you will get imaginary solutions, then you can solve that one, okay? Then remember, if you have negative inside square root, minus 4 root, likewise don't take this minus outside, okay? This is completely wrong. So you can do here is minus 4 root equal minus 1 root times root 4. Then here I 2, 2i. Now any other simplification process, okay? You can't take minus sign outside from the square root. That's the thing. Okay. Now let's practice complete square method. Let's practice complete square method. See this one. So I'll revise you again. Here ax squared plus bx plus c equals 0, quadratic equation general form. Here first you divide by a, first step, x squared plus b divided by ax plus c divided by a, 0. Now second step, you write this a, purpose square, here x, here same sign plus, here x coefficient you divide by 2, then write here b over 2a without x and constant c of a and subtract square of this. That's the procedure. Then x plus b over 2a whole thing square, take these two the other side. Here b squared over 4a square minus c of a. Then simplify, get common denominator, then 4ac. Then get both sides square root. X plus b over 2a equal, here plus or minus b square minus 4ac divided by 4a square minus b over 2a, here b square minus 4ac over 2a, then minus b plus or minus b square minus 4ac root divided by 2a. Now we're going to practice this procedure. So previously we had done this one directly formula application. Now we're going to practice this procedure now. Here this procedure we call complete square method. Okay. If anybody missed this one, just write it. That procedure. Now see one example. X square plus 2x minus 1, 0. Then here x square coefficient 1, then no need to divide. No need to divide. Then write purpose square. Here x square write x, sign plus, x coefficient divide by 2. 2 divided by 2 mean 1, write it here without x. Then here minus 1 constant, subtract square of this. Subtract square of 1. Then simplify x plus 1 square minus 1 minus 1. Here 1 square, then minus outside. Don't take that one as plus. Then x plus 1 square minus 2, 0. X plus 1 square equal to, then x plus 1 plus or minus root 2. Then x equal minus 1 plus or minus root 2. Okay. Then using direct formula you can obtain this. By this process, again you have to practice. Do that example. Previous procedure you have to practice. That is called complete square method. You know this sum, but anyway, we have to practice more than that. Okay, second one, x square plus 4x minus 1, 0. Here coefficient 1, then write x plus x coefficient 4, you divide by 2, minus 1, then subtract square of this. Then simplify x plus 2 square. Here 1 minus 4 minus 5, take the other side, plus 5. Then x plus 2 equal plus or minus root 5. Then x equal minus 2 plus or minus root 5. Do with me. Okay. Then example 3. Example 3. Do with me. 2x square minus 3x plus 1. First divide by plus, say plus 2. First divide by 2. Let's say plus 3. Divide by 2. X square minus 3 divided by 2x plus 3 divided by 2. At first step, we need to get x square coefficient 1. That's why we're going to divide by 2. That is first step. Then second step, you write purpose square with this constant. Then write x here, same sign minus. Here x coefficient you divide by 2. Then 3 divided by 2 divided by 2 means 3 divided by 4. And here 3 divided by 4 square. Here x minus 3 divided by 4 square. Here 3 over 2, 9 over 16. Simplify x minus 3/4 square. Then get common denominator 16. 24 minus 9, 15, 0. Okay, here 16 common denominator, 8 into 3, 24 minus 9, 15. Then x minus 3/4 square minus 15 over 16. Now get square root both sides. X minus 3/4 plus or minus minus 15 over 16 root. Now we know how to simplify this. Then plus or minus root 15 I, no? 16 root mean 4. Then x equal 3 plus or minus 15I divided by 4. Here it is. 3 plus or minus root 15I divided by 4. Continue. Okay, now you try these questions. Continue. Follow proper steps. Take time. Okay, check first two questions. x square minus 4x minus 5. Here x minus x coefficient divided by 2 minus 5. Again we have subtract square of this. Then x minus 2 square, don't mislead here. Here 2 square 4, then 5 minus 4, 9. That's the thing you have. Okay. Then x minus 2 square equal 9. X minus 2 plus or minus root 9 means 3. Then x minus 2 equal 3, or x minus 2 equal minus 3. Then x equal 5, x equal minus 1. That one we can factorize. Last week we have done factorization technique. No? Then here we have factors, but anyway using complete square method you can obtain. Then x square minus 6x plus 1. Then here x minus 3 square, 1 minus 3 square. X minus 3, 1 minus 9, 8. Minus 8. 3 plus or minus root 8. Further here you can simplify 2 root 2. Root 8 means 2 root 2. No? Likewise you can go. Take further little time. See another two. X square minus 8x plus 2, 0. Here put x. Sign minus x coefficient 8. No? Now divide by 2 plus 2 and subtract square of this. Then x minus 4 square. 2 minus 16. 14. Root 14. Then x square plus 12x plus 1, 0. Write x, write plus x coefficient divide by 2 and subtract square of this. Then x plus 6 squared, 1 minus 36, 35. Then get square root, plus or minus 35 root. Then last one, x square minus 5x over 2. X square minus 5x over 2. 5x plus 2. X coefficient divided by 2 subtract square of this. 5 over 2 square, subtract. Now simplify. Here 4, 8, 25. 17 over 2. 17 over 4, no? Here 4, 8, 25 minus 8. 17. Get square root. Plus or minus. Okay. Further you continue. Further you continue. Follow procedure. Do simplification. Check two questions. X square plus 3x minus 1 0. X plus x coefficient 3 divided by 2 minus 1, subtract square of this. X plus 3 over 2 square 9 over 4. Here 4, 9, 13 over 4. Put the other side. Plus or minus 13 over 4 root, subject x. Continue. Then x square plus 5x plus 2. X plus 5 over 2 square plus 2 minus 5 over 2 square 0. 5 over 2 square 25 divided by 4. Here 8, 17. Plus or minus root 17 over 2. Continue. Okay, see another two. X square minus 3x minus 5 0. X minus 3 over 2 square minus 5 3 over 2 square 0, x minus 3 over 2 square 9 over 4, 3 over 2 square 29, x minus 3 over 2 29 over 2, plus or minus. Then x square plus 7x minus 1 0, x plus 7 over 2 squared minus 1 7 over 2 squared 0. Here 1 minus 49 over 4. $53 over 4. And subject x. Then 2x squared 4x minus 3 0. Now that divide by 2. First you have to divide by 2 here. Take this coefficient 1. Then do following technique. X plus 1 plus or minus root 5 over 2. Okay, then last one, 2x square 3x plus 5 0. First you divide by 2. Now x coefficient divide by 2, then this will be 4. And subtract square of this. X minus 3/4 square. Take common denominator 16. Here 40 minus 9, 31. No? Now we get imaginary solution. X minus 3/4 square minus 31 over 16. Now get square root both sides. X minus 3/4 plus or minus 31 over 16 root minus now. (31 over 4 root I) minus 1 root I, no? Okay, let's do another two theory questions. Take time. Okay, I'll do two questions. Check your answers. 2x square minus 3x minus 1 0 divide by 2 now. Now previous procedure. 3 over 2 divide by 2, 3 over 4. Minus half, subtract square of this. Now simplify. Then subject x. X equals 3/4 plus or minus 17/4. Then 3x square minus 2x minus 1 0. Now divide by 3. Perpet square. Here x. Here minus x coefficient divide by 2. 1/3 here x. 2/3 divide by 2, 1/3. 1/3 minus 1/3 square. Here 9, 3, 4. Plus or minus 2/3. Minus 1/3. Here you can factorize as well, but we done that one using complete square method because you need to practice that one. Continue. See another 2. 2x square minus 5x plus 3. Do simplification carefully. Divide by 2. Now write x, write minus x coefficient divide by 2. Here 3/2. Subtract square of this. 5/4 square, 3/2, 25/16. Simplify. Here common denominator 16. 1/16. No? Here 8 into 3, 24, 25 in 1/16. X minus 5/4 plus or minus 1/4. X minus 5/4 equal 1/4, or x minus 5/4 equal minus 1/4. Continue. First divide by minus 3 and write this way. Here 2/3 divide by 2. Better write 1/3. Here 2/3 divide by 2, 1/3. 2/6 also correct, but better write 1/3. Simplest form better write. Then x minus 1/3. Here x minus 1/3 square. Here 4/9 plus or minus 2/9, 2/3. X equals 1 or x equals minus 1/3. Three x square minus 4x minus 50. So 4/3 divide by 2, better write 2/3, or 4/6 also possible, but better write simplest form. Then x minus 2/3 square, 5 over 3, 4 over 9. Plus or minus 19 over 3. Okay, then 20th one, 5x square minus 4x plus 1, 0, first divide by 5. Now write x minus, here x coefficient divide by 2, subtract square of this. Here common denominator 25, 5 minus 4, 1. Here 5 minus 4, 1. Get square root 1 over 5 I. Here minus root, no? Then 1 over 5 I. Two plus I divided by 5, complex solution. Okay, then we have done today equation, especially quadratic equation part, especially how to solve quadratic equation with imaginary solutions. And also we have done things about imaginary numbers, complex numbers and so on. Those are very important things when you are doing A-levels. So next day we can do furthermore equation part regarding quadratic pattern equations and also simultaneous equation part. Okay, then that's all for today. See you next week.